Hi there, it's Danny B from Danny B Tutoring, and today I'm going to show you how to use the kinematic equations to solve a motion problem in physics class. Now, these four equations only work when the acceleration is constant, okay? But the four kinematic equations are delta x equals v naught t plus 1/2 at squared, v equals v naught plus at, delta x equals 1/2 times the quantity, v naught plus v times t, and v squared equals v naught squared plus 2a delta x. Now you'll notice that in those four different equations, there are only 5 variables that are being used. And I write them down on the left-hand side of my paper whenever I'm about to solve a motion problem using kinematic equations. So I write down tax VOVA is how I remember it. It's t delta x v naught v a, tax VOVA. Now, t represents time. Delta x represents displacement, how far something is moved. Now, you might be used to using d or delta s, but I've used delta x. V naught is the initial velocity, or the velocity when the time in the problem is 0. So typically at the very beginning of the problem, how fast is it moving? That's v naught. V is the velocity at some later time in the problem. Oftentimes it's at the end of the problem. Or it's linked to this time right here, or you could think of being linked to this displacement right there. So after 20 seconds, how fast is it moving? Or after 25 meters, how fast is it moving? That's what that V is representing. And finally, A, of course, is the acceleration. Now, to solve a kinematic equation problem, right, a motion problem, what you first need to do is identify which of these 5 variables are you trying to figure out. What I do is I write down tax VOVA on the left-hand side of my paper, I read through the problem, and I figure out, oh, this is a problem where I'm going to need to find the displacement. And so I will put a box around the delta x, and I'll remember it's now my goal for this problem to figure out what the displacement is. Then as I read through the problem again, I might make some notes as to what would be the v or the v naught maybe, and perhaps I've got the acceleration as well. I might be missing time, or I might have all the information. It doesn't really matter. But if I'm missing something, that's actually okay, because each of these equations is missing something. And we can use that missing piece to actually be the key to use to figure out which equation to use. So, for instance, this first equation has no final velocity. You see that it has the initial velocity, but v by itself does not show up in that equation. The second equation has no displacement. Delta x does not show up. The third is missing the acceleration. And the fourth has no time involved. Okay? Now, for the problem in question, we have a person pushing a stroller starting from rest, uniformly accelerating at a rate of 0.50 meters per second squared. What's the velocity of the stroller after it has traveled 4.75 meters? Notice in this problem, we're looking for the velocity sometime later. So that's why in my chart here, I'm going to highlight V, okay? Now I go through everything else that I happen to know. So for instance, it told me that the person started from rest. Okay, well that really means that the initial velocity is 0 meters per second. They started from rest. They're accelerating at a rate of 0.5 meters per second squared. So I come on down here and I'm going to fill in for acceleration 0.5 meters per second squared, right? Okay, and it also says that it's moved 4.75 meters. So that's the displacement. All right, so I'm going to come up here, find the displacement, 4.75 meters. All right, and I hit the question mark. I'm at the end of the problem. So what do? I identify that I have no time. I've got no time for this problem. All right, I've got an equation with no time in it. V squared equals v naught squared plus 2a delta x. So I'm going to use that equation. Okay, copy it over here. I'm going to use this equation here, v squared equals v naught squared plus 2a delta x. I'm going to plug all the pieces where they belong, and I'm going to solve for the missing piece, which would be the v. All right, hope that helps.